Welcome to WEFTEC Now. My name is Travis Loop from the Water Environment Federation. Very pleased to be joined by Peter Grevatt, CEO of the Water Research Foundation. Peter, thanks for coming on.
Hey, Travis, great to be with you. Thanks for the opportunity to join you.
So I'm very excited to talk to you about a variety of research going on in the water sector, always so critical to be advancing science and understanding. One of the biggest issues in water is PFAS. What's the latest with research on PFAS?
Oh, Travis, PFAS is a really big issue, and if anything, it's only going to get bigger over time. We've got about $73 million of research underway right now, and quite a number of projects on PFAS. And one of the most important projects, a new one we just launched, that I think is just critical for the water sector, is actually a focus on alternative strategies, Travis, to prevent PFAS entrance into treatment plants. Because we know PFAS is not being introduced at wastewater treatment plants or drinking water utilities. It's coming through the environment, and the water sector is the recipient of these pollutants. So we're really focused here on alternative strategies to keep PFAS out of the water treatment facilities in the first place. And we know it's going to be a long road to get there. That's a reason why we're also focusing a project on one water messaging on PFAS, because utilities of all sorts are going to have to be reaching out to customers to be talking about PFAS. And in fact, Travis, you and I both worked on the unregulated contaminant monitoring rule process that EPA ran when we were there. Well, it's time for UCMR 5 that includes no fewer than 29 PFAS compounds on the list that utilities are going to be required to sample for. So there's going to be a lot of conversation with customers about PFAS. So we have a project focused on one water messaging. We have another project that I think you're familiar with, and many of the WEF members will be, that's tracking the fate of PFAS through water resource recovery facilities. We've got 25 participating utilities. And one of the big questions is, how much of the PFAS is going to biosolids? How much might be released in effluent? And how does the utility manage those challenges? And well, there's a few other projects. I could go on all day, Travis. I know we don't have that much time, but I will tell you that we're also thinking about studying the fate of PFAS through sewage sludge incinerators for the utilities that use that technology, and also application of a novel method to measure total PFAS in water rather than trying to go compound by compound by compound. So just a little snapshot of some of the work we have going, but it's really quite comprehensive on PFAS.
One of the other topics that's front and center right now is climate change and the need to build resilience to climate change. That might not be something that we just know how to do. We need to have some more science on that front as well. So you have some research going on climate resilience?
Well, of course we do, and we have for a number of years. And I think the thing that I think about, Travis, regarding climate is that these days, the most predictable thing about climate seems to be unpredictability. And whether we're thinking about storms like Katrina and Sandy and Harvey, or most recently Ida, or the extraordinary drought across so much of the West, impacting so many millions of people across the country and frankly around the world, the unprecedented intensity of wildfires we're seeing, it seems like everywhere we turn with regard to climate, extremes are the new normal. And when I was watching the predictions, as so many of us were for Ida, honestly, Travis, the last thing that I thought is that we would be seeing people drowning in their apartments in and around New York from a storm that came up through Louisiana. It's just stunning what we're seeing happening. And so that's why climate resiliency has been such an important focus for the Water Research Foundation. And whether it's our new project we just launched, focused on holistic and innovative flood management under extreme wet weather and climate impacts, or whether it's the case studies that we're doing on management of cross-sector dependencies to address the storm like the 2021 Valentine's Week winter storm that put the entire state of Texas under a winter storm warning. And you'll recall that storm took out the power grid and interrupted water service in communities all across the state, caused $1 billion of damage. That storm, the Valentine's week storm, cost more in terms of the damages than even Hurricane Harvey in 2017. So these cross-sector dependencies are really important focus for us. We're thinking about, in terms of wildfires, we have a project we just launched that's focused on post-wildfire distribution system water quality impacts and potential responses. A real surprise, I think, for many, that once a fire comes through, within the distribution system, there are all kinds of compounds that may be popping up, particularly for folks who are using plastic pipe. And it's just a new challenge that I think many didn't anticipate. We have some process control studies we've just launched, including one on filtration process control for pathogen removal and climate change adaptation, and another project on holistic wet weather management through adaptive volume and pollutant source control at a community scale. So Travis, there's a lot going on community resiliency to climate change, and we know there's really a desperate need for this research going forward.
I know that the Water Research Foundation has also received a number of grants for research on some other key topics, and I would love to hear what's going on each of these from you. One is on improving energy efficiency and resource recovery at water facilities. What are you looking at there?
Yeah, thanks, Travis. This is a really exciting grant from the Department of Energy. And we know, and this has been such a focus of WEF over the years, that water resource reclamation facilities have made incredible advances in resource recovery. And yet, it's still the case that water and wastewater treatment facilities consume as much as 3% of the energy across the US. And the monitoring and data collection and control processes that are used even at the most advanced water resource reclamation facilities, by and large, use 20th century processes for monitoring and control systems. And these require very large design safety factors to ensure reliability, and reliability, of course, is essential, but to ensure reliability in the absence of more advanced and precise controls. And we recognize that there are significant reductions that are still achievable in electricity consumption, in chemical input, in greenhouse gas emissions, as well as improved energy recovery, perhaps over 50% improvements in energy recovery. And then at the same time, we're confident that we can achieve smaller design safety factors for more precise designs through improvements in process monitoring control. So we have this really exciting project, Travis, underway with the MWRD folks in Chicago, with Hampton Roads Sanitation District and DC Water, who between the three of them have invested $2.5 billion over 10 years on intensified resource-efficient municipal wastewater treatment. And by implementing sensors and algorithms, decision support methods on 5 different emerging water resource recovery process technologies, we're confident we're going to be able to see significant improvements in energy recovery from wastewater, while at the same time minimizing both the electrical and intrinsic energy demand. So this is a diverse test bed across these 3 utilities and 5 different processes, where we're confident we're going to be able to develop and demonstrate next generation process control systems that can be tailored to meet the needs of a diverse set of water resource recovery unit processes. So it's a big deal, Travis. We're very excited about it.
We have decades of science on biosolids. They've been very studied for a long time, but science is always changing, and there's a need to continue to push and look. And I think you all are going to be doing some studying of biosolids and maybe some of looking at for unregulated organic chemicals there. What's happening on that front?
Hey, that's right, Travis. And we're so pleased that the Water Environment Federation was able to join us on this EPA grant. We're so pleased to be funded by EPA. And it's a part of our effort to conduct studies to evaluate the fate and transport models in risk assessments for various constituents in biosolids. And, biosolids have been safely land applied for many, many years. And we're now seeing increased interest in biosolids as a result of concerns about trace contaminants, PFAS, and otherwise. And so we're conducting this study that's really going to help us understand some of the constituents, not only the constituents, but also how they behave in the environment, to make sure that we can factor this into risk assessments and provide the public confidence necessary that that these processes are safe and effective. And we expect this project that, as I noted, we're doing with WEF. We're so excited to have you as a partner. We expect that's going to lead to recommended best practices to reduce or manage potential risks of unregulated organic chemicals and biosolids and biosolids amended fields.
Another thing that's important is water reuse. You mentioned the incredible drought that's in the American West that's not really going anywhere with climate change. Water reuse is being just continually looked at as a potential solution or a path forward to water sustainability. What are you all doing on that front when it comes to research around water reuse, its safety and its reliability?
In fact, the Water Research Foundation has the most robust research portfolio on direct potable reuse of any entity on the globe. I mean, we have extensive research projects that we have underway, about 25 research projects, including the work that was funded by the California State Water Board that interestingly produced the most robust data set on the levels of pathogens in raw wastewater anywhere on the globe. Collected data from 5 different water utilities all across the state of California over a 14-month period. And this project is integral to understanding the levels that are necessary for log reduction values for pathogens, which are really at the core of policies and regulations for direct potable reuse. So that's a project that we just finished up, but another project that we just launched, another one we were very fortunate to be just recently funded by EPA for, is a project that's focused on improving public health protection through the development of quantitative data on the removal of human enteric viruses by treatment processes through direct potable reuse treatment trains. So there's a lot there, but another piece that's focusing on the removal of enteric, human enteric viruses. And these data are going to help to contribute to the development of data-driven log reduction values. So not just making assumptions about what's necessary for log reduction values, but really producing the data that's necessary that underpins those. And so we're going to be quantifying the removal of human enteric viruses by different treatment trains at 5 different full-scale water reuse facilities across the US. We're going to define appropriate surrogates for these human enteric viruses because it's not always easy to measure the viruses themselves. We're going to validate the virus and the surrogate removal by challenge testing at engineering scaled systems. And then we're going to also develop these risk reduction and log reduction values using quantitative microbial risk assessment. So this is such an exciting project. And as you noted, it is a time when we need to be thinking about water reuse, and this is going to contribute right to give the answers that we need to make sure that we can expand this work and do so safely.
Technology is such a great tool for water utilities, obviously. There's smaller systems, there's private wells that might not be able to use technology as well or might just need some help kind of streamlining its use and putting it into effect. What are you doing on that front, research-wise, to help small systems and private wells?
Well, thanks, Travis. I appreciate the question. It's such an important one. And as you know better than anybody, there are far more small systems than there are large systems by far across the United States. And so you're right. Technology adoption for small systems is a big challenge. And you mentioned private wells as well. And as it turns out, we were fortunate, again, to be funded by EPA this year on a project where we're actually a sub to the Association of State Drinking Water Administrators on a project focused on bringing emerging technologies that can be used at smaller systems and private wells. And one of the biggest challenges, Travis, in introducing these technologies is not with the development of the technologies, but it's with getting these technologies approved at the state level. And what many innovative technology developers typically have to do is go state by state by state trying to get approval. And it's just an insurmountable challenge to move a technology into practice in the field. And so this grant is all about working with states to try and find ways to hopefully get to a point where we can get some reciprocity from one state to another. And so if a state says, hey, these folks are my neighbors here, they've done a terrific job evaluating this technology, it's good enough for them, we think it's going to be good enough for us. And the only way to get to a place like this is to be convening state leaders together and talking about the processes. Again, building confidence, making sure that we have the approaches that are going to work and be acceptable across the board. So that's the focus of this grant. We're really excited about it. It'll also touch on private well owners, and there are many, many private wells across the country, as you know. So another really exciting project. So we're covering a lot of ground here, Travis, and really glad to be able to share this information with everybody who's watching today.
Yeah, fantastic. Very exciting. I'm looking forward to seeing all that information come out. Great research projects planned there. Peter Grevatt, CEO of the Water Research Foundation, thank you so much.
Thank you, Travis. You take care.